factoring by decomposition here. So what we have here is a trinomial. A trinomial is something where you have three terms. So if you remember when we talked about that common factoring, when you have an addition or subtraction sign in between numbers and variables, they separate terms. So in order to use decomposition, we use it with a trinomial, and this happens to be a quadratic. The variable with the highest power happens to be the number 2. So this is a quadratic. So this is a very common form of moving from what's called the standard form of a quadratic to the factored form. Okay, so this is an important process to know in order to do that. Why would you do that? Because factor form, when you look at it, it'll quickly find us usually x-intercepts of a graph. Okay, standard form really only gives us y-intercepts. It does a really good job of it. In fact, looking at this right now, that's my y-intercept, -2. So if that was a graphic, great. But what are my x-intercepts? This form is not very helpful. So we change forms algebraically so that we can graph a little more information.
Yeah, so if I want to find the y-intercept, I'd use standard. But if I want to find the x, I then factor.
Yeah, factoring is a better style. It's easier to use. I mean, you can start plugging and randomly and trying to find it, but that's very tedious and inefficient. So we use this for efficiency. Okay. So decomposition literally means in mathematics to break something apart. So what we're actually doing is we're breaking apart this middle term. What they use is an algorithm called product and sum. So they sometimes call it P and S for product and sum. And what you're trying to find, we're going to write out the general equation for a standard. It's ax squared, have you ever seen this version, plus bx plus c. Have you ever seen it written this way? They'll write it this way. This is a general equation for standard form, and so that we can refer to positions of coefficients and constants.
Yeah.
So like the A position in this case is 12. Yeah, B is -5, C is -2. Okay, so for decomposition, what we're looking for is we're looking for two numbers that multiply to what A times C is. Okay, so in our case, that happens to be 12 and -2. I'm gonna have to make some room here. Oh, that ruins everything. Okay. I'll just squeeze it in. A times C, which is 12.
You can erase it if you want to.
Yeah, that's okay. -2, and we get -24. So we're looking for two numbers that multiply to -24.
And then two that equal 5.
That's it. They equal the middle term. Now, not just 5,
-5.
but -5. That's important, that piece. Okay. So I will tell you that numbers that add to -5 are infinite. I can find tons and tons and tons of them. Numbers that multiply to something that are whole numbers gets a little smaller. So it's best to kind of try from here. Look for my factors here is what they would be called. So two numbers that multiply to 24. Well, we got 12 and 2, but I can't add them for -5.
Yeah.
1 and 24, again, I can't make a 5 of that. So we just start going through them. 3 works out really nice, actually. 3 times 8 gives us 24.
Yeah.
Okay. Now, so let's put it down here. 3 times 8. And 8 and 3, they don't quite make 5, but there is a difference of 5. And if we notice, this is a negative. So in order to do this, +8 times +3 is not -24. Yeah. One of these has to be negative. Yeah. The question is which one? One specifically will give us -5 here.
-3.
Okay, let's see it. 8 plus -3, that'll actually give me +5. I need the larger number to be the negative.
Because it's just gonna
which is okay. It takes some time to practice to see that very quickly. So we need -8 and +3, and that will give us the multiplication of 24, and that'll give us the addition of -5. Great. What do we do with these two numbers? Well, this is what we talked about before. This is that concept of decomposition. So I'm going to write it out again. And what we're doing is we're literally decomposing, or we're taking apart -5. And the way we're doing that, move this down a bit, is we're going to say 12x squared stays the same, but now instead of writing -5, I'm going to write -8x plus 3x, and then -2. How is that decomposition? Well, if I actually put these together, -8x plus 3x, I get -5. So this is like a less simplified version. The reason we do this now is we're going to find common factors, which is what we were practicing before. We're going to find common factors from the first two terms and the second two terms. And it doesn't matter if I put the 3 here or the 8 here. It's going to actually work out every time in the end.
Okay.
So think of it like I need a common factor for this pair, and I need a common factor for this pair. So we look at them. I got my coefficients. 12 and 8. Quickly off the top of my head, I know 4 works. 4 works really nicely. So I'm going to say my common factor here for sure is going to be a 4. And then we look at our variables. I've got 2 variables. They're both x. Great. The lowest one is to the power of 1. So that's the one I write. I can't write to the power of 2.
Yeah.
Same concept out here. What do we got? 3 and negative 2. My common factor is 1.
Yeah.
And I have 0 variables that'll work. There's no x here. So I'm actually going to be common factoring out the value of 1. Okay. There's a trick to knowing if this works. So first we write them in. 4x. And then in brackets here, I got to do my division. Well, 12 divide 4 is 3.
Yep.
X squared divide x is x. Negative 8 divide 4 is negative 2. X divide x cancels out.
Yep.
Okay. And our next one, well, my common factor was 1. What's in the brackets? I'm left with the exact same stuff. Nothing has changed. This is where we do a check. Are these brackets the same?
Yeah.
They are. If they are, boom, check mark, we've done it right. If there's a difference, something went wrong and we probably got to backtrack and fix something.
Oh, yeah.
Okay, so this is a really good checking point. We'll solve this the checking point.
So first you find the product and sum, and then you factor.
Yeah,
Common
you
factor.
decomposition and then you common
yeah.
factor. Yeah, it's like a big algorithm. It's quite a process to do
Yeah.
this. Once you do it a lot, it becomes second nature. But when we talk about every step, there's a lot. There's a lot to explain in it. Now, what we're actually doing again is we're technically common factoring again. This one's a little harder to see, but this is a common factor. This bracket and this bracket, these are the same thing. I can divide this term and this term by this bracket. This idea is hard to see. I'm going to kind of show you over here. I'm going to use a little let statement. I'm going to say let a equal 3x minus 2, and I'm going to rewrite it. When we do that, we'd be left with this. Y is equal to 4xa plus 1a. Now, if we look for common factoring, a comes out of both, okay? So we write it equals here. Y is equal to a times what would be left? Well, we'd have 4x plus 1, okay? And then we would have to put in what a was originally equal to. Well, a was originally equal to 3x minus 2. And then what's left in the other bracket? 4x plus 1, okay? So a lot of times your teacher will skip this over. They'll say, you got 2 brackets now. You're going to make 1 bracket of this and then 1 bracket of the other 2 terms. That's a great way to think of it. This is the actual algebra. This is actually what's going on, but you don't have to show that every time.
Can you do that part one more time?
Absolutely we can. Let me go to the bottom of this. I'm going to do another one like it. So usually the shortcut is they say this. Make a set of brackets, take 4x and positive 1 and just put it in one of them. And in the other bracket, just put the other 2. Okay? And that's technically it. That's your factored form. But this part got tricky. So I'm going to give you another example of this. I'll go below. So I'm just making this one up, okay? We have a scenario like this. 3x plus 1 minus 2x plus 1, okay? My brackets are the same. So technically like in common factor, but it's hard to see this. So I use a let statement to make it simpler. I'm going to say let a, I should put a little x here. Yeah, I'm going to put a little x here just because that's important for this piece. Let a equal x plus 1. Otherwise, we can do this simplification. I don't want that to happen here. So we get 3x, and I'm going to color code it, a. Remember, a has replaced that entire bracket, okay? Minus 2, a. A has replaced that entire bracket. Okay, let's common factor. Only one common factor here. It's just a, all right? I could take 1. We could say 1 is here, but it's not going to change anything. It doesn't do anything. So now we're common factoring out a. So I take out a. What am I left with? Well, I'm left with, when we divide, these cancel out. We have 3x. And when we divide here, these cancel out, minus 2. Great. But I can't finish the question with a because there was never an a to start in the original question. We did this little thing. So it's actually good practice to write that statement again. Let a equal x plus 1. I forgot to put an equal sign here. Okay. And this is us saying, hey, we're going to change it back now. A is actually equal to this. So we're going to replace a with this bracket. That's what we originally did. We swapped it out and then we're swapping it back in. The reason we did this is so it was a little simpler for us to look at. So instead of writing a, I write this bracket, x plus 1. And what's the other bracket? 3x minus 2. This is that same concept where they'll just tell you, hey, take these 2 terms, put them in a bracket, and these 2 are the same, put them in one bracket. You don't have to carry this process out. I just wanted to show you that that's what's going on.
Is that called something?
It's just common factoring again. So really what you're doing for decomposition, this is why teachers don't always show all the processes, but really what's happening here is you're decomposing, so using your product and sum, then you decompose, then you common factor, and then you actually common factor again. So there's actually 2 steps of common factoring, okay?